All right, so we're about to have a fashion show where we're going to hear from some amazing thinkers. Now, here's a real lesson for us all. They've all been given 2 minutes to give their presentation, except the first company, because they're a sponsor. So if you want more time on the program, there's a few ways to get it. One is to sponsor the program. So can we please give it up for SCM?
All right, thank you. So I'm not so sure about the genius part. I think we have a much better plan than being a genius. So I'm Paul Spiering. I'm the machine learning developer at SCM. And already for half a century, we have been making and maintaining software for researchers. It always fills me with pride when about our main product, AMS, the Amsterdam Modeling Suite, I see this quote by Roald Hoffmann. What I really like about the Amsterdam Modeling Suite is that the programs were clearly written by chemists for dealing with chemical problems. A great suite of programs. Or in our own words, we make user-friendly software so that researchers can do their job faster and better. So how do we do this? We keep in touch with the latest developments and research. We also have a graphical user interface that you can use to perform complicated tasks easily. And we have expert support, meaning that if you have an issue with the software, you do not talk with a random person that doesn't really know what's happening. You actually talk with a software developer or a chemist, or even better, most of the times you get someone who's a software developer and a chemist. And also our software runs on many platforms as well as in the cloud. So, of course, we have to ask ourselves the question, where does AMS fit in the fifth paradigm of chemistry? And I think we're in a great spot, but we're not quite there. AMS actually has two phases. So on the one hand, we have the engines, which compute properties for a specific arrangement of molecules. So that's, for example, ADF, band, DFTB, ReXFF. And on the other hand, we have the AMS driver, which then uses these properties to compute emergent properties. For example, you can use the potential energy surface from any of these methods and then compute properties about diffusion, about reaction mechanisms or reaction barriers, and also about mechanical and thermodynamical properties of materials. The reason why we think we're in a good spot is because of the following reasons. Is that we already have 5 decades of experience, half a century, and we've seen what happens when the kind of software that is available changes and how to deal with that. We've seen a change in demand and a change in supply of algorithms. We also have a Python framework, and this is Plums, and this is actually an open source framework, and it's freely available on GitHub, and this is used to tie together all the different components in our modeling suite. And then we have the support by our developers that are actively interested in learning more about the research that everyone is doing, so we are able to connect to our customers directly and talk to them about the latest developments. And what's also really important is that all of our inputs and outputs, they are documented very well. There are units available and also a human readable text that explains what these inputs and outputs are about. And there are a lot of tutorials. And especially this, I think, is going to be important once large language models are going to catch up and be able to make use of this knowledge that we have already available. We also have consulting and training for if people do not have the in-house knowledge to perform these calculations. Now, actually, today I'm not here to sell AMS. I'm coming here with a better plan, and it is to work on collaboration. I think that's the main theme of here today. And we really like collaboration. And one of the main pillars of collaboration for us have been European Union grants. They help us in 2 ways. First of all, it forces us to make products that tackle problems in society. Otherwise, you do not get the grant. On top of that, it also mitigates some of the risks for making these kind of products by partial or complete funding. Now, we also have a lot of experience of going from idea to product. And this has been especially helpful for us when we collaborate with startups, so that we can help in that respect. For more established partners, we really like to make joint products. This is a great way to find new customers, to find each other's customers without competing, and makes you able to sell your product to a larger group of customers. And finally, for researchers, we provide a lot of increased visibility and outreach. So we help with maintenance of the code and also with usability of the code, so that in the end, once a research project is finished, it can actually be used without needing to do a PhD yourself, and also after half a century, the code will still run. So how do we connect AMPs with AI or machine learning or basically any project? So the technology is quite insane. AMPs or its components might have some outputs, and machine learning might take these as inputs. Or on the flip side, machine learning might have some outputs, and AMPs could be using this as some input. Okay, so what does this look like? For example, Intelligence, a UK-based company, has used AMPs to compute properties. In this case, these were homolumo gaps as well as dipole moments, and they were able to use this in their machine learning framework, where they do design of experiments to find new molecules. And when they use the properties from AMPs on top of structural properties that you would normally use, they get a much better result. And on the flip side, we like to really use universal potentials, which means they are already pre-trained, so they do not need to be trained again, and they work for many systems. And so if you want to do some research, I really advise you to make a pre-trained model that works on essentially all systems. So we have a couple of things that we work on ourselves. So we have params, which is actually a fitting program or a parameterization program for classical force fields and also density functional tight binding. And we are adapting this to machine learning now as well. So that what you've already been done, what you could already do before for classical force fields, you can now do for machine learning. Once this has been implemented in AMPs, we can think about active learning loops. So in this case, we started fitting for a graphene sheet with a water molecule on top, and then we try to do some molecular dynamics, get some results, and then refit based on the engines that we already have in our suite. And once we're happy with the system, we can go to a more complicated system. In this case, a carbon nanotube with water inside of it. And then, of course, the dream is going to be large language models that are going to help to write these workflows. I don't think it's quite there yet. But in this case, it was possible to obtain a piece of code that actually runs, so it doesn't crash immediately, but which is quite impressive already, although I do not understand why it was going to do a calculation for a CH triple radical. But okay. So if you are interested in us, please talk to me or my colleagues, Maria and Feder, who are also around. And we are really looking forward for collaborations. Thank you.
So you can't see it, but Paul can, and he literally closed in the final 2 seconds of his 8 minutes. This is very impressive. So now, everyone else in the fashion show has exactly 2 minutes. And Marco, my dear friend, is on the clock. So you can see he's kind of like a DJ. If you look down, you can see he's got a little control pad in front of him, and this has a countdown clock, which has exactly 2 minutes on it. And so our contestants in the fashion show have all risen to the challenge and said, we'll present within 2 minutes. So they need a lot of love when they come to speak. And they're really asking you to talk to them during our 1 hour break. So keep notes, think, who am I going to speak to? Because they're there for you. So big round of applause. Our next contestant, C.
Thank you, Tim. Hi, everyone. Good evening. I hope you are enjoying ChemAI as much as I am. My name is Mariana. I am here representing CCTC, the Cambridge Crystallographic Data Center. We are an associated company of Cambridge University, and we are focused on advancing structural data. I want to talk briefly of one of the main challenges that AI and machine learning are facing at the moment. This problem is the poor quality of their training data. It's logic that if you have low quality data, you will have then low quality results. It's a fact then that you need the proper training data in order to have the trustable and correct results that you need for making decisions. And this is where we can help. CCDC can provide you with high quality and curated data. We own the CSD, which is the largest database of small molecules, including 1.25 million of structures at the moment. The CSD can provide you insights that can help you to develop your projects. On top of this, our scientists have developed knowledge-based software solutions that can help you to develop new molecules or drugs, materials, and as well particle engineering or analysis and structure prediction. We offer tailor-made solutions for small and medium-sized companies as well as for academia. Leading companies of the industry like BASF, Bayer, Pfizer, and even Meta are already using our technology. This is just a brief introduction of what we do, but if you are interested or have any questions, you are welcome to come by the stand and we will have a nice talk. Enjoy your evening, and thank you very much.
Thank you so much. So we're off to a great start. And next up, please welcome to give us exactly a 2-minute pitch. Now he's wishing that he had sat on an aisle seat. Never take the window seat when you're... Come on down. Give him a big round of applause for Findest.
Thank you. Yeah, now I had even more time. That's fine. What can you do without technology? So my name is Vincent Franken. I am an entrepreneur. Started my company here 6 years ago, not that far from here, a couple meters, I think. And we started with just 2 people as an AI technology scouting company. And nowadays we've grown into a company with over 30 employees. Maybe some of you have heard of us. Findest, and we over 400 customers by now. I should update this slide. And what we have is an AI-based technology scouting platform, specifically for research and development organizations. And as you can see, it's useful in almost all industries, as long as they do R&D, and they need also chemistry and physics. And what we do is we find technologies. That's technology scouting. And we do that by looking semantically into scientific literature, patents, company websites, startups, everywhere. So what are all the potential solutions in the world that could solve a specific challenge? Challenges like finding alternative materials, finding sensors, developing flying cars. Could be anything. And at ChemAI, of course, we're specifically focused on chemistry. So Gaia is here, one of our chemistry experts. And she can show she can show real chemistry cases where we use this algorithm to find, for example, chemical substitutes. So if you look at PFAS or PFOA in firefighting foams, you want the AI called eager.ai to understand what is the firefighting foam hired to do, and what are the other chemicals that could potentially do the same job and even better. And of course, we have a process for that. Typically, you want to first look broadly. What are all the potential technologies in the world? And then you want to dive deeper. Are they actually going to work? Are they fast enough? Are they strong enough? All that sort of stuff. And we did, in the past couple of years, over 2,000 real projects, gathering a lot of data and making the AI a lot better. And we are aiming to implement 10,000 innovations in the next couple of years. That's my time. Thank you.
All right. Our fashion show continues. So if you're going to create a great company, you need 2 things. You need a great concept and a great name. Please welcome to the stage, Essentia.
Hello everyone, this is Ahmed Khalil, founder and CEO of Essentia. So before I tell you what Essentia is, I would love to ask you a question. I would love you to be interactive with me. Of course, you're on a chemistry-related event. So anybody here works in the lab or have work related to the lab, please raise your hand. Right, we have a really nice audience. Do you resonate with any moments in the lab when you are multitasking between many things, trying to run your experiments, write down your notes, things sometimes goes wrong? Do you resonate with that? Please raise your hands. Do you resonate with the moments when you go outside of the lab, look back to your notebook and try to remember what's going on, what did you do exactly, and spend endless hours into updating your electronic lab notebook? Do you resonate with that? That's why I'm here. Thank you very much, and that's why we created Essentia. Essentia is a highly specialized voice assistant for scientific labs, so you think of it as the Siri or Alexa for scientific labs. It integrates seamlessly with your existing solutions like electronic lab notebooks, LIMS systems, or even machines, and enable the scientists to access and document data through hands-free voice commands. So we are currently working with multiple labs around the world, from biotech, pharma, to agriculture, research, to food and beverage industries. We're helping them to accelerate their digitization process and hopefully eliminating the work or the manual documentation and paperwork. So if you're curious how Essentia works and you want to see Essentia in action, I'm more than happy to show you the demo downstairs in the fashion show. Thank you very much.
Great job. And he left 13 seconds on the clock and made it just look like. So next up, who do we got? It's VLCI. Come on down, VLCI. Give him a big round of applause.
Yes, thank you very much. To go to the next slide, of course. So my name is Sander Verloon, obviously the founder of VLCI, Verloon Chemical Innovation. I started the company like 15 years ago already. And now we are a bunch of science-based formulators providing R&D services to companies all over the world in the field of coatings, personal care, home care, well, whatever has to do with recipe developments. That's what we are into. We provide our services to all those companies, but with a unique business model. We're using Hansen solubility parameters and hydrophilic lipophilic difference in order to characterize ingredients. It gives a very predictive parameter to all kinds of ingredients. HSP does that for solutions and dispersions, and HLD does that for emulsions. By giving those parameters to ingredients, you can then fill in the thermodynamic equation, and then you can find matching ingredients. And basically, you're going to match ingredients together in order to create a very happy environment. And what do you do in a happy environment? You perform to the utmost. So that is basically what we do here. So we provide this as a service, but we also have now web apps. The HSP-based web app is called Pretty Match, and the HLD-based web app is called Pretty Emulsion. So you can make pretty formulations by predictive science of those parameters. People can purchase a licensee on the web app, and it contains the world's largest shared HSP and HLD database of commercial ingredients. So within a couple of minutes, you can develop your product, find 100 times faster your matching, replacing or bridging agent, and narrow down formulation space a 10-fold. And again, it's 10 seconds away, so thank you very much.
Our contestants definitely came ready to play this game, so thank you very much. So next up, Biolytics AI. AI is in the name. Give them a big round of applause.
Hello, I'm Hugo from Biolytics AI, and we're on a mission to revolutionize the R&D of life sciences companies. We do this by focusing on 3 primary areas, which is the development of advanced machine learning models, the engineering of robust machine learning solutions, and the crafting of AI implementation strategy frameworks, all to accelerate the R&D of life sciences companies. Now, that's still pretty abstract, So let me make that concrete with some examples from clients. The first is a biotech company that was inundated with vast amounts of data generated by their cancer treatment analysis tools. And for them, we helped them to leap from a cumbersome collection of hard drives to a seamless cloud-based AI lab. This enabled them to connect their machines directly to machine learning algorithms that extract relevant insights for their scientists, which can drastically increase their research efficiency. The second case revolves around AI in healthcare, and specifically for elderly people. We're partnering with a company called Gerimedica to develop clinical decision support systems, which help doctors to make treatment plans. They have roughly 7 minutes to create these plans for their patients, and our AI learns from vast amounts of patient data in order to predict their recovery timelines and help personalize these care plans. And our final example revolves around something pretty hypey around ChatGPT. We needed to structure millions of descriptions for a client, but they couldn't use ChatGPT in this case. So we helped them to make a small model that extracted a single ChatGPT skill, and we could deploy it inside of their infrastructure. We made it cost effective and very fast. So that's just the tip of the iceberg of what we do at Biolytics AI. If you're curious about what AI can do for your organization, please visit us at biolytics.ai. And that's it. Thanks for your attention.
And they can meet you right downstairs in just a few minutes. So, all right, exactly, wonderful. So, company fashion show continues here at ChemAI, and as you might see from the animal on the screen here, you're expecting to see something from the Matterhorn. Dun dun dun. So please welcome to the stage, Matterhorn.
All right, thank you, everyone. Just gonna sit this on here. All right, I'm Jacob. I'm a PhD at UCL in London in machine learning. I'm also a research scientist at Matterhorn Studio. We provide you with peer-reviewed plug-in Bayesian optimization for your self-driving laboratory. So who has a self-driving laboratory? Raise your hand. Yes, Aiden has one. So Aiden had a lab tour this morning, and he has a really nice self-driving laboratory. Self-driving laboratory means you fully automate all the steps. So you characterize, you measure, you synthesize all with just labs and robots and stuff. And so every self-driving laboratory, actually we're going to have a workshop on it, workshop 2 as well. So Elmo's going to talk about that as well. And join that instead of the other one. Every self-driving lab has a brain that makes decisions what experiment to run next. And so that's usually done in machine learning with something called Bayesian optimization. But Bayesian optimization can be a bit complex at times. It's intransparent if you don't share the code. And if you want to collaborate on it, you also need to be kind of smart with the tools. And so instead of all of that, we've created something called the Op Store, which is like the App Store on your phone, but for Bayesian optimization algorithms. And so you see here, we have algorithms from Facebook and Berkeley and University of Toronto. And all of these are available to you with one single click. Well, it doesn't just stop there. Every algorithm here actually also has a GitHub repository, so it's all transparent. You can just go and fork it as well. So who knows how to use Git? Come on, guys. Good. Thank God. And so with Git, you can just take a pipeline, fork it, and make your own adjustments, and also, again, add it to the Op Store, not the App Store, the Op Store. And so here on Matterhorn.studio, you can also try tutorial, or you can just visit me later. Or if you're just interested in our petting zoo, you can do that too. So this is Matty, our mascot, has an Instagram as well. And I'm looking forward to see you at the company showcase. Thank you so much.
I love it. This fashion show has everything, including mascots. What more can we ask? All right, bring up our second to last contestant, Zeta Alpha.
Thank you. My name is Jakub Savrel from Zeta Alpha, founder, with a group of about 12 AI and search technology specialists based right here in Lab 42, so kind of a home game. And for the last couple of years, we have been pioneering the use of AI for connecting people and knowledge, in particular for R&D teams, at the exciting junction between neural search, basically embedding queries and documents in high-dimensional vector spaces for information retrieval, and generative AI, large language models like GPT that allow us to summarize and answer questions. And these vector embeddings allow us to build, to do great search and recommendations, but also to build semantic maps of the domain. Like here, for example, all the recent papers of the last 3 months in the AI for chemistry domain. So come to our booth to see where your research interest lies on this map, but also to find out how you can use retrieval augmented generation to use GPT like large language models on your own company internal information to improve factuality and transparency, and have GPT on your own proprietary material. This allows us to do question answering on your private documents, to talk to documents while you're reading them, and powers the research assistant that guides your whole discovery journey. And because search has become so important with this retrieval augmented generation, we also want to talk to you about how we've managed to almost double the search relevance for the chemistry domain by fine-tuning over baseline embedding models. Thank you.
And I know what everybody is thinking, is they're thinking, if the last one is as interesting as all of these, you're going to be very busy during the break. So, last but not least, please welcome UB Ops.
Hi everyone, I am Gijs from UB Ops. I have one question for you. Who's working with AI here today? Hands? Very nice, very nice. Well, if you're looking to deploy your algorithm, then UBOps can be the solution for you. It doesn't have to be, but it can be. What UBOps is a way, if you have your Python code ready, you've built a great algorithm and you want to deploy it, you want to build a web service, or you want to build anything, you can use UBOps to add compute power to your algorithm. So that's what we do. The best way to get to know UBOps is to see it. I love to demo it downstairs, so I'll keep it short. That's UBOps. Will help you deploy your algorithm, and hope to see you downstairs.
Very nice. Thank you so much, UB Ops. So that was a great fashion show. Before I move forward, I want a big round of applause for all our contestants.